Our project is on Mie scattering through a medium, and this is for Optics 3330 for Andrea Hill and Beckah Hufstetler.
The purpose of this lab was to prove Mie scattering by scattering it through a cuvette that we filled with different concentrations of a milk water solution. So for this, we also were supposed to 3D print something to contribute to the experiment. So we tried to 3D print a phone case, protractor, and different gears to rotate the phone around the protractor, but the 3D printer couldn't print the correct sizes of what we needed, so we just had to go buy them.
Background on Mie scattering. So Mie scattering is elastic scattered light of particles with a diameter similar or larger than the wavelength of the incident light, which in this case was our Heaney laser. It comes from Gustav Mie, and it takes the form of an infinite series of spherical multipole partial waves. The term Mie theory sometimes is used for the collection of solutions and methods, and it doesn't necessarily refer to an independent physical theory or law, but rather suggests situations where the size of the scattering particles is approximately equal or larger than the wavelength of light. It also often takes place in the lower 4.5 kilometers of the atmosphere, where there might be many essentially spherical particles with diameters similar to the wavelength of the sunlight. So the scattering intensity through a medium is proportional to the square of the first scattering intensity and the second scattering intensity, dependent on cosine of theta. And both S1 and S2 are infinite series. The first over 2L plus 1 over L times L plus 1 times A sub L pi sub L plus B sub L tau sub L. And for S2, it's the same, but instead it's A sub L tau sub L plus B sub L pi sub L. A sub L and B sub L are dependent on the spherical Riccati-Bessel functions. Pi sub L is proportional to the Legendre polynomials, an infinite sum of them, and then tau sub L is proportional to the derivative of the Legendre polynomials.
So to perform this experiment, we had to create the device you can see in the picture on the right. We hot glued a phone case to a compass, and then we hot glued a protractor to a piece of cardboard. And we put one end of the compass through the hole at the bottom of the protractor and the other side on the rounded edge with the degrees so that we could rotate it around those degrees so that we could measure the light at varying angles.
For our experimental setup, you can see we used the phone, we angled it so that the front-facing camera would hit where the laser shined through our milk solutions that we made, and then we used that to collect data, moving the phone along the protractor at various angles.
To measure the intensity of the light, we used the iPhone app called Google Science Journal, and it gave us the intensity in lux, which we then used in our calculations for Mie scattering. So here you can see our data with each concentration of milk. So we did 4 different concentrations, and for each concentration we took 10 different angles, and then we measured the relative intensity at each of those angles.
This is a sample of the code that we wrote. L is our index for the infinite series, and due to the size of the code, we were only able to go up to 5 for our index, because then after 5 it gave us an overload error for the code. We also had to hand calculate the derivatives of the Legendre polynomials, which was another issue that we had for the timing and the size of the code. However, we were able to get a decent approximation, we hoped, from this, from our experimental data. And in this, you can see all of the steps that we took, which we iterated over L from 1 to 5, and then used that as our data points for our graphs.
So here you can see a graph of where purple is what it should be according to the equations for the relative angle plotted with the measured intensity. And then each of the different colors are the different data that we took for each concentration.
For our first concentration, 1% milk, we got a p-value of 0.8192 after fitting to several free parameters in the code. So we figured that this was not a super great representation of our data as it relates to Mie scattering, as it's not a very low p-value, which we somewhat expected after seeing our data and how complicated the math was behind the infinite series and how many factors there were, and also because our infinite series was not quite so infinite and only went up to 5. The second graph is for our 0.5% milk concentration, and it was slightly worse fit at a p-value of 0.89.
Continuing on with these two graphs, you can see the 0.1% concentration and the 0.01% concentration. We got p-values of 0.8171 and 0.8802 respectively.
So overall, our data did not fit very well to the correct math, even when we optimized our free parameters. As you could see previously, the graphs visually didn't line up super well, and they also had relatively high p-values, which indicates that the goodness of the fit is not very good. Some sources of error that we anticipate is that maybe 10 data points was not enough for our calculations, and we should have done using every 5 or 2 degree increments rather than 10. One thing that would help quite a lot would be to have a more powerful computer so that we could take a better approximation of the infinite series. And then we also would have liked to maybe look at different media with different refractive indices, but there wasn't enough time for us to do that.
So in conclusion, there was a lot of different error sources that gave us the results that we got for this lab. So like she said previously, we could have taken a lot more data points that would improve this lab a lot. And also using a phone to capture the light intensity probably wasn't quite as accurate as using like a voltmeter or something a little more that has more precise measurements or can go into more detail. And also the approximations we took while calculating the math would increase the error because it wasn't the exact precise answer. So overall, if we had been able to prevent these errors or redo the experiment, adjusting for them, the experiment would have been very successful. And we would have been able to demonstrate Mie scattering through a medium.